In this video, we will make a module to test the WT2003H4-16S MP3 decoder IC. We will work on this module, starting from drawing the schematic, until it is ready for use. The WT2003 IC is an MP3 decoder microprocessor produced by Weitronics. One variant of this IC is the WT2003H4-16S, which we will make a module for in this video. To find out more clearly the description of this product, we can see the datasheet. WT2003HX is a powerful and high-quality MP3 chip upgraded from the MP3 chip of WT2003S. MP3 Control. Standard UART communication interface. The default baud rate is 9600, which supports settingbaudrate through serial port command. Support SPI-Flash, TF card and U-disk as memory. With the functions of file index play, spot insertion, single loop, all tracks loop, random play, etc. Level 32 has adjustable volume, and can support 128 megabits flash, 32 GTF card and 32 GU disk at the maximum. One thing that is unique about this chipset is that it has a built-in 0.5 W Class D power amplifier, so that this chipset can be connected directly to the speakers. Of course, the DAC audio output is also provided, so you can develop various audio products using this product. Other technical information please read it yourself later on the datasheet. I tried to order directly from Weitronic. Unfortunately, my request to order a sample chipset was not responded to by the sales. Maybe they only serve large orders, or only serve large customers. Finally, I ordered a sample of the product at lcsc.com. We start by drawing the circuit schematic. Here we use the Eagle application. We add ICWT2003. Then SPI-Flash memory. In the module that we are going to make, the MP3 files will be stored in the IC SPI-Flash memory. Okay, we have finished working on the circuit schematic. Hopefully it can be seen clearly. Next we will lay out the PCB. The PCB design that we make will use single-layer FR4 PCB material. We will make this PCB as efficient as possible. Even though it's only one layer, we will try not to use jumpers for the paths between components. The most interesting part when designing a PCB is when positioning the components, and making the paths that connect between components. Like putting together a puzzle, we of course have to take many things into account. What you see is not the best design of course. But we are trying hard to make this PCB work properly. Okay, our PCB layout is almost done. Here I will add some text. This is the jumper pin for the USB connector. This is the jumper pin for the speaker. This is the jumper pin for serial data. And this is the jumper pin for the power supply. This is for the positive power supply. We mark it, so that there is no wrong installation. Now we will print this PCB layout. Because it only has one layer, namely the top layer, we have to mirror the printing. Okay, let's print now. This is the PCB layout that has been printed on PCB Paper Transfer paper. We will paste the image on this PCB. The following is the PCB transfer paper that we have pasted. Now we will open the results of the transfer. We will open slowly. Okay, the result of the transfer is quite complete. There are only minor flaws here and here. We will correct this defect using a waterproof marker. The markers I use are OFP markers. You can buy them at bookstores or other stationery sellers. Oh, missing title for USB pin jumper. I will write it manually. Okay, next we will do the etching process. After we flush with clean water, we dry the PCB using a tissue. Next we will do the drilling. the PCB that we have drilled, then we clean the black ink, so that the copper layer is clean. Then we cut this PCB to size. Thank you for still watching this video. We deliberately present this content slowly, with the hope that all stages will be presented clearly. Now we will start the soldering process. This PCB is made simple, with simple materials. Only one layer. It's not the best handmade PCB, of course. However, just to test the basic function of a component, we think it's enough. If you want to buy this WT2003 chipset, please be careful. Look at the product code to suit your needs. If you read the information on the website, the program on this IC can be configured, or we can ask the manufacturer to configure the program according to our needs. Is that right? The method? I do not know. Please contact yourself. I pray that you will get good service. This IC packaging is SOP16. As long as you like soldering, I'm sure this component is very easy for us to solder by hand. For MP3 file storage, here we will use SPI-Flash WinBond W25Q16. Of course, you can use a memory IC with a larger capacity. Okay, now the components are soldered. As you can see, the supporting components are only a few pieces. Very efficient. We will connect serial data here later for control. And for the process of uploading MP3 files, we will use a USB connection over here. Now we will attach the jumper pins. Oh yes, we will give this PCB the legs, so it can stand straight. For that, in every corner we will give a seat. This is a magnetic holder. So if you place it on iron, it will stick like this. The header pins are supposed to go like this. But that means they're at the bottom, which would be a pain. Then we will install it in the following way. This is just a simple trick of pin header installation. But who knows, there are hobbyists who don't know. Let's prepare the speakers first. Just use a small speaker. This pin is the DAC output, which we don't use on purpose first. So here we will use the built-in amplifier IC to drive these speakers. We have finished the soldering process. This is not something sophisticated or high-tech. But we make this video in earnest. And we work hard on it. As your support, please like, comment, and subscribe to this channel. Okay, we are now ready to test the module we just created. The first thing we do is upload the MP3 file to this SPI-Flash memory. For this process, we use a USB connector to connect the module to the computer. The USB connector that we will use is like this. On the other end it has a micro USB connector, and of course we will use a USB cable like this. We plug the female header into the USB pin header on the module. And we connect the USB cable to the computer. As you can see, the module is immediately recognized as a USB storage, the computer, and confirms to format the storage. We write the label, for example WT2003. On capacity information, data storage is detected at 2 MB. And we format. Now let's see our WT2003 data storage info. SPI-Flash memory has been detected as data storage in general. Here we can see the info that we usually see in a data storage. I have prepared 3 MP3 files which we will upload. The process is just copy-paste. And it doesn't require a special uploader application. These 3 files have a total size of 768 kilobytes, while earlier the storage capacity was 2 MB, so we can include these 3 files. We copy-paste. We check again the capacity info now. Can you see? The file that we uploaded earlier is a sample MP3 file. Let's listen to it first through the audio player on the computer. The first files. The second file. And finally, the third file. Okay, the upload process is complete. Then we eject USB data storage from the computer. Next we will try to control the module using the serial command. As the CPU we will use this Arduino. This is for the power supply. Black wire for ground. We connect here. For the positive 5 volt, we connect here. Because we don't need it, we remove this USB connector first. Then these 2 cables are for TX and RX from the MCU to the WT2003 module and vice versa. WT2003's TX pin is at pin 16, and its RX is at pin 6. These are connected to pin 2 and pin 3 of Arduino respectively. We install the speakers. Here we have written the Sketch program. We write the code like this, very simple, right? We see from above. This is the declaration of the RX and TX pins. This is the menu list. The menu selection will invoke the following program commands. Menu 1 for the Play File 1 command. Menu 2 for the Play File 2 command. Menu 3 for the Play File 3 command. Menu 4 for the Loop command. And Menu 5 for Play or Pause commands. Let's see the command format of each menu. Play Command 1, serial data format like this. Note that each command always begins with code 7E, and begins with code EF. And the code between the two is the specific command code according to the command that we will send. Let's take a look at the datasheet for the serial command parameters. What must be remembered is that the default baud rate is 9600. And the start protocol and the end command are like this 7E, and end with EF. Because we are using flash memory, the command target storage is A1. Pay attention to the following play file command. After the start code, we send the message length info. Then followed by the target storage. Then if we choose to call according to the file name, then the protocol is like this. For file 0001, we send the command in ASCII format, which in hexa is 30303031. Then after the file name we send a checksum message according to the calculation of the series of codes that we package or send. Okay, you can read the protocol information or other command parameters yourself if you are interested. We connect the Arduino to the computer. Then we upload, sketch or control our MP3 WT2003 program. We open the serial console. This is the menu we created. Let's try menu 1. Then menu 2. Then menu 3. We try the play menu 2 more times. we try the play or pause menu. Now let's try the loop menu, where if this command is sent it will play a file repeatedly. Okay, we've done a quick trial. Of course, this module is only a sample of WT2003 IC utilization. For real needs, just adjust. For example, we add a microcontroller to the module, and other accessories can be added as needed. Thus we provide this short video. Hope it is useful.